All right, so in class we did a sunflower activity, which I'm not going to go over in this class. But we did simple random sample for one of them. We did stratified by row, which means per row we picked one. And then we did stratified by column, so we picked per column one. And we found averages of sunflowers within each plot. And we plotted them on a dot plot in class together to see. And we saw that this one specifically had a very small spread compared to the others, and that the averages were about the same, the centers were about the same on all of them. So because we were doing, we were using graphing calculator to sample randomly, they were good at predicting the center on all of them. But as you can see, this is even better because it's also a small spread, and that was due to the fact that the sunflowers were different from row to row in the number of sunflowers per plot. Sometimes grouping them by a specific characteristic will give you better results. That was the point. The point is grouping by row gave us better results because it's not only the center accurate, but it's also spread is very small. We want that. It's closer to the truth. All these numbers were closer to the truth than these were. About that then. Sometimes grouping and then choosing from each group randomly is a better option. And that's called strata. These are groups that share the characteristics that are same. So when you do a stratified random sampling situation, then you're selecting a sample from each stratum, each group. Strata is plural, stratum is singular, and it just means group. But it's very specific to groups that share characteristics that are the same. So some examples are like grade level, ninth graders, all ninth graders, 10th graders, 11th graders, 12th graders. If we were to pick students from each grade level, and like equal numbers, so like 10 or 50 ninth graders, 50 10th graders, 50 11th graders, and 50 12th graders, then we would be doing stratified random sampling. And if we were picking those 50 using a random random sampling method, such as slips of paper, technology, or random digits table, etc. Or we could stratify by gender if it matters, or we could stratify by type of course if it matters. So you shouldn't just stratify for the sake of stratifying. You need to stratify with some kind of goal in mind. If you think the results will be affected from the different groups that exist in your population, you should stratify. That is good. If you don't think it will affect the results, then there's no point in stratifying. And each stratum have to be homogeneous in a sense that they're similar to each other. So the grade level, every grade level is similar to each other. All the ninth graders or the freshmen are ninth graders, and they're similar in age. Maybe they're similar in the courses they kind of take, that kind of thing. A cluster is also a group, but each cluster is usually located near each other, and this is called cluster sampling. But also, the clusters are heterogeneous. They mirror the population. This is kind of important because within each cluster, like one cluster should be similar to the entire population. If it's not, then that is not a cluster, and so that is important. For example, all residents who live on a block in a city. Okay, so the cluster is the block and all the people in the block of a city. They're located close to each other, and perhaps they are mirror the population. They should mirror the population. If they don't, then you should not do the block system in a city. Okay? Or a section at an auditorium. And if students are sitting all mixed groups, for example, and if you just take one section of the auditorium, and as long as within each section there's a mixture of 9th, 10th, 11th, 12th graders, for example, then you'd be doing cluster sampling. A third type of sampling is called systematic random sampling. And basically you're choosing you're choosing the first K individuals by randomly. So this is going to be easier to explain with numbers. But let's say the population, you're choosing a number from 1 through 30. And you choose, 15. 15 is the random number that's chosen from 1 to 30. Then every 30th number after that, 15. So the first one would be 15, then 30 more, 45, then 30 more, 75, etc. And you would be choosing every 30th number after the first random number that has been chosen. Okay, and how do you pick that 1 through 30 part depends on your story. So we're going to do an example and you'll see what that entails there. So randomly selecting a number from 1 to 10, example 7, then inspecting every 7th product from a production line. So then it's like 7 every 10th. This is incorrect. Oops. Every 10th product from a production line. So this would be, the first one would be the 7th one. Then add 10 to it, 17. Then add 10 to it, 27, 37, etc. This is the every, kth number, basically. Right. All right, let's look at some examples in the next page. Here's one that's a massive example. The student council wants to conduct a survey about use of school library during the first 5 minutes of an all-school assembly in the auditorium. There are 800 students present at the assembly. Here's a map of the auditorium. Note that the students are seated by grade level and that the seats are numbered from 1 to 800, and here is what the breakdown is of each. Describe how to obtain a sample of 80 students using simple random sampling, stratified random sampling, cluster random sampling, and systematic random sampling. All right, so let's do the first one. That's easy because simple random sample is just take all students 1 through 800. So label students 1 through 800, the same as what their seat number is. Use graphing calculator. I just chose graphing calculator to make it easy. Use graphing calculator to select 80 random distinct numbers. Doing that will give you 80 students basically, and this is your simple random sample. Then you give the survey to each student associated with the number. This is not very efficient, as you might experience. If you have this kid to give the survey to, then this one, you're talking about several rows. These are a bunch of rows in between that are not in the picture. This is not the size of the auditorium. It's way bigger, right? So it's going 1 through 20, 21 through 40, etc. And bunch. These are the last two. There's way more in the middle, as you can see with those dotted lines. So this would take forever to do. Stratified random sampling. Well, we could stratify by groups that are similar, and groups that are similar in a school setting is the grade level. So 9th graders, 10th graders, 11th graders, 12th graders, these are the strata. Okay, and so we're going to label 9th graders maybe 601 to 800 because they're sitting in those seats, for example. And then maybe 10th graders 401 to 600. There's different ways to do these, by the way. Don't think of it as the only way. 11th graders 201 to 400, 12th graders 1 to 200. And then use graphing calculator to select 20 random distinct numbers from each grade level. Why 20? Because we need 80. And since there's 4 grade levels, it's 80 divided by 4, which is 20. From each grade level, give survey to each student associated with the numbers. So this is definitely, since they're seated together, it might be easier to, it's more efficient, but still kind of bad to do. It's really not as efficient as some of the other ones, okay? But definitely more efficient than this one, time-consuming wise, to run around within sections. So you're only running around within these seats at a time. Maybe you can appoint one student to hand out the surveys there, one student there, one student there. Then divide and conquer. Cluster random sampling. Okay, so this one was hard to think about. You have to figure out a cluster, things that are sitting together, close together, but you also want to represent all grade levels, because if you only just pick, one row, you'll get 20 students in one row. If you pick by row, I'm going to get 20 students, but I'm going to get only seniors if I pick this first row. If I pick only the last row, I'm going to get, only ninth graders. And if I pick two, because there's 20, 20, 40, 60, we need 4 rows. If we went by rows, we need just 4 of them. But we could get all freshmen or all sophomores or all whatever, and that would not be very good because the sample does not represent the population. So how can we make sure we get a mixture of even numbered of grade level kids without doing the stratified random sampling? Is go by rows instead. Columns instead. You're going by columns instead. So you got to figure out how many rows there are, therefore how many people are in a column. In one column, there are 40 people. So we just need 2 columns. If we pick one column, we get 40 rows. One row has 40 students of equally numbered grade levels, so 10 of each. So in one column, there are 10 freshmen, 10 sophomores, 10 juniors, and 10 seniors. So that's good. That means it'll give me 40 kids, 10 of each grade level. And if I pick 2 columns, then I'm set. I have my 80 students. So you're going to label the columns 1 through 20. And then you're going to use your graphing calculator to select 2 random distinct numbers. Give the survey to each student sitting in that row, it says. Mistake. Column. Let me fix it. And it's a different color, but I don't care. As you can see, this would be super efficient. So if you stood right here, let's say we picked 11, column 11, you give all these kids here, 40 kids, you say pass it back, and it would be super efficient to pass out the survey in that way. We're just assuming the survey is paper here, because then why else would you do any of this? I mean, you could say, give a QR code to all these kids, and so it's not a paper, but give a QR code, then it is digital. I suppose you could make this digital. All right, and then the last one, and this is definitely more efficient because it's fast. Per column, 2 columns, done, 80. Okay, so the last one is the systematic random sampling. So there's 800 students and we need 80 students. Usually you can take 880 and then you get 10. That's the number from 1 to 10. You need to pick a random number from 1 to 10. And then you're going to do the every 10th number after that. So there are 800 students. We need 80 of them. 800 divided by 80 is 10. So use the graphing calculator to select our number from 1 to 10. Let's say we picked the six one, like 6 was our number from 1 to 10. Starting with that random number, basically 6, give the survey to every 10th student after that. So basically it's the 6th, the 16th, the 26th, the 36th, the 96th. That gives us 10 right there from the first 100. And then if we keep going, you could see that this gives us 80. If you don't believe it, you can count it individually. But from 6 to 96, the first 100 numbers, it gives us 10 numbers. And since there's 800 numbers, we're going to get 80, 10, like 8 tens. So 80 survey. And that will result in the number of exact number of people we need for our survey.